of the mathematics. Now, today we move forward to the 2006 MIT Integration B finals. Problem number 1, which happens to be the indefinite integral of cosine of x over cosine of x plus sine x. This is a tricky but simple problem to work on. So let's see how we may be able to solve it. We're going to use to solve this problem, first method. We would like to express cosine x over cosine x plus sine x as the integral of half the integral of 1 plus cosine x minus sine x over cosine x plus sine x. So you may be able to do that because if you rearrange that fraction in the integrand, you would get twice cosine x over cosine x plus sine x, and that means to remove the 2, you'd have to append that constant half. So we could create two separate integrals from that. So we have half the integral of 1 plus half the integral of cosine x minus sine x over cosine x plus sine x. Now, in the second integrand here, what you can see is that the numerator happens to be the derivative of the denominator. So we can re-express it as half the integral of 1 plus half the integral of the derivative of cosine x plus sine x over cosine x plus sine x. And so integrating 1, it becomes half x plus we have, if you have a function that is a fraction whose numerator is the derivative of the denominator, we know that to be, when integrated, to be the natural logarithm of whatever is in the denominator. And so what we have here is half natural logarithm of cosine x plus sine x, obviously plus the integration constant. And that is it. That's what was required of us. Now we'll also look at a slightly longer method for solving this, and that is going to look at the second method for solving this problem. Cosine x over cosine x plus sine x can be re-expressed in a different way by multiplying by cosine x minus sine x to both the numerator and the denominator. So after you do that, what happens is the numerator becomes cosine squared x minus cosine x sine x, and the denominator becomes cosine squared x minus sine squared x. So looking at this part of the numerator, since we know sine 2x to be twice sine x cosine x, that means that sine x cosine x becomes half of sine 2x. And also looking at cosine squared x, since we know cosine 2x to be cosine squared x minus sine squared x, as shown here, it means that this is also equal to twice cosine squared x minus 1. And that also means that cosine squared x is equals to a half of cosine 2x plus 1. So using these three relationships, we can now go ahead and re-express our fraction as half cosine 2x plus 1 minus a half sine 2x all over cosine 2x. So we can pull the half out, and we have cosine 2x minus sine 2x plus 1 over cosine 2x. Okay, now let's continue. We have half the integral of cosine 2x minus sine 2x plus 1 over cosine 2x. What that means is that now we can divide each part of the numerator so that we have half the integral of 1 minus tangent of 2x plus the second of 2x. And it's easy to integrate this. It becomes now half. For 1 we have x. For negative tangent 2x, it becomes half natural logarithm of cosine 2x. You can stop there and prove it further. And then secant 2x is half natural logarithm of secant 2x plus tangent of 2x, then plus the integration constant. The integral of secant 2x is a popular integral. The integral of tangent x is a popular integral. You can do a further dive into that and look. But if you do request for us to prove that, you are free to leave us a comment on the comment section, and we'll be able to duly help you with that. So we have half x, half of x plus half natural logarithm of secant 2x plus tangent 2x, and since we have an addition here, rules of logarithm, we multiply cosine 2x to all whatever is under the log function, and so that becomes half of x plus half of natural logarithm of 1 plus sine of 2x, and obviously plus the integration constant. You can go further and say, well, the integral of cosine x over cosine x plus sine 2x is equal to half the natural half x plus half natural logarithm of sine 1 plus sine 2x plus integration constant. Obviously, you can simplify that further by saying, okay, 1 is cosine squared x plus sine squared x, and then sine 2x is 2 sine x plus cosine x, and that means that that is the same as cosine x plus sine x squared. And using rules of logarithm, the 2 can go out there, and so we have now half times x plus natural logarithm of cosine x plus sine x, obviously plus integration constant, and that